To check what I write, mathematicians.
What the probability
Mathematicians.
of me unenabling biases
Mathematicians.
when having inequalities?
Mathematicians. Hold up. Check your work. Computing areas, quadratic formula, graphing parabolas. I think they're all so cool. It's my sole commitment that I ace the regions. Sine, cosine, and tangents are my favorite tools. I divide, multiply, I subtract, round off, and simplify. I divide, multiply, I subtract, round off, and simplify. Is a whole, rational, vector, a substitute, solve for x is a whole, rational, vector, hit the pie.
Hey guys, so there's another installment of our Mathematicians song. We're going on to 8.2 now in this lesson, analyzing arithmetic sequences in series. We'll be identifying arithmetic sequences, writing rules for those arithmetic sequences, and finding sums of finite arithmetic sequences. So we're going to go through all those three things in this lesson. So at first, let's go on to a little quick cartoon, as we usually do. Far side again here. So it says, careening through the neighborhood with reckless abandon, none of them suspected that Tuffy was still tied up. You could just hear the with the dogs joyriding through the neighborhood. All right. Okay, so there in your vocabulary, it's write down for arithmetic sequence. Basically, that arithmetic sequence is just where you're going to have there's a difference of consecutive terms is constant, and so you can write that down. The difference of the consecutive terms is constant. So you're either adding or subtracting. For arithmetic sequence, and I remember writing this on the board, you can do this where you're going to add or subtract the same number each time. So you could also write this, arithmetic sequences are basically adding or subtracting the same number each time. And that same number is called the common difference. So the common difference is that constant difference that you're either adding or subtracting. That's what we call with this common difference. So for common difference, you can write down that's the number that you're adding or subtracting every time is called that common difference. It is denoted by D here. So when we see the letter D, we're going to be that's going to represent common difference. That's going to represent the constant rate of change. It's very much similar to the slope. So this is similar. The D would be similar to the slope, which is your constant rate of change. So you may want to put that down here. It's similar to slope, because we are talking about linear equations here with arithmetic sequences. An arithmetic sequence is a linear function. It's another thing you may want to put down here as well. Another thing we can say for this is that these are the linear functions. So we can think of it in terms of like a y equals mx plus b kind of equation. So when we write the rules, it's going to be like that, in that kind of form. Our y, remember, is going to be a of n. So in this one, a of n is what's going to equal y. So we're going to say a of n instead of saying y. Instead of x, we're going to put n instead of x on this one. So this is what we're going to do on this chapter. This is a little different notations, kind of more the sequence notation. Okay, so on our extra practice, page 224 there in your notes, it says tell whether the sequence is arithmetic, explain your reasoning. So for 1 through 4, that's what we're going to do. So we're looking to see, is it arithmetic, which means it's going to have a common difference. So is there a common difference between these numbers? Are we just adding or subtracting by the same number every time? So we could start just with the first two. So we would be to 1, we're going to add a 3 to get 4. And then go from 4 to 7, we're also going to add 3. So far, it looks like there's a common difference. To go from 7 to 12, though, we're going to be adding 5. And then 12 to 17, and adding 5. So this one, it doesn't have a common difference. If you just check the first two, you might have gotten this one wrong. You have to make sure that you look at all of them so that there is always going to be a common difference on all the numbers I give you. So no, this is not arithmetic, because there is no common difference. That would be our reasoning. No common difference would be our reasoning. Number 2, between these first two, from 26 to 23, we're kind of subtracting. These ones are going down, so we're going to be subtracting 3. And then to go from 23 to 20, we're also subtracting 3. And then 20 to 17, subtracting 3. And then 17 to 14, we're also subtracting 3. So every time we are subtracting 3. So that is a common difference of negative 3. That would be our D in this case would be negative 3. So we'd say yes, it's arithmetic because it does have a common difference of negative 3. Number 3, we're looking at these ones. They are going up, 0.3, 0.5, 0.7, and so on. And we can start going through. To go from 0.3 to 0.5, we would add 0.2. And then 0.5 to 0.7, we're also going to add 0.2. 0.7 to 0.9, also 0.2. And another 0.2 gives us that 1.1. So yes, this one also is arithmetic, and it does have a common difference of 0.2. That would be the reason. So yes, for arithmetic, common difference would be 0.2 every time. Now number 4 might be a little more challenging because it has these fractions. We're going 1/2, 1/4, 1/6. We are going down. These are getting smaller. So we want to say, okay, what's the difference between these first two? So you'd want to take pretty much to subtract 1/4 minus 1/2 to see what that difference would be for those first two. So 1/4 minus 1/2, you need a common denominator, so that's going to be 1/4 minus 2/4. That would be a negative 1/4. So the difference between the first two is negative 1/4. Let's find the difference between these next two. So 1/6 minus 1/4, and see if that's going to be the same as a negative 1/4. So we get common denominators here, so this would be a 12 for the common denominator. So it's going to be 2/12 for the 1/6, 3/12 for that 1/4. And now we could say basically 2 minus 3 would be a negative 1. So we're getting negative 1/12. So right there you can see it's not the same common difference. Negative 1/4, then the next one will be negative 1/12. So no, this one cannot be arithmetic. There is no common difference on that one. Now on page 223, you'll see this core concept. Now this core concept is for us to write a rule for an arithmetic sequence. Now remember, a rule is simply just an equation. So that's what you might want to write this down is. If you forget that, you can just say, well, what they mean by a rule here is an equation. So this word rule, they're going to use that to represent, basically what an equation is. And kind of more of their, function form. So this is our function form. So like your y equals mx plus b, your a of n is y. Instead of x, we're going to use n, as you can see there. Now this right here is important. You want to highlight that right there. This is the kind of formula for writing out a function. Now a of 1 just means your first term. You want to write that down and show that's what that means. First term is a of 1. The d here, that's your common difference. It's kind of like your slope number, like I've said before, but that's the common difference. That's the number you're adding or subtracting every time. And then we want to just basically plug things in here. So the only two things we need to know to be able to write a rule is your first term and is the common difference. So if we know that, like on this example here, your first term is 3 and the common difference is 2. So we can plug in right here for a of n, we're going to put in 3. So a of n is equal to 3, that's the first term, plus n minus 1, that's always going to be that way, n minus 1 times d. D is 2, so you distribute this 2 in here, combine like terms, and you get 2n minus 1. So that would be like your y equals mx plus b equation. Remember, these are all linear equations on this lesson in 8.2. Okay, so back to page 224, the next 4 problems in the extra practice. They want us to write a rule for the nth term of the sequence and then find a of 20. That means the 20th term. So they give us on this one the first 4 terms in our sequence. Now these are all going to be arithmetic, which means they're all going to have a common difference. We don't have to figure out if they do or not. So the only ones they wanted us to figure out was like those first 4. If they said, okay, is it arithmetic, then you're trying to figure that out. But when it does say write a rule now, you can just kind of assume these are going to be arithmetic. So we just need to figure out, okay, what's that first term and what's that common difference. So I wrote the formula right here again, and all you got to do is just plug it into the formula and simplify, and you got your rule. A of n, remember, is the same thing as like our y. So a of n equals the first term, a of 1, plus n minus 1 times d, and you just got to fill in the first term and that common difference. So on the 5, you can see in our first term is obviously the first number, so 3 is our first term. A of 1 is 3. That common difference, you're going to add 6 to 3 to get 9. So the difference between here is 6, and you can see it's continuously being 6 all the way through. So your common difference here is positive 6 because it is going up. If it's going down, then it would have been a negative. But if the numbers are getting bigger, then you're going to be a positive common difference. So it's d is 6. We're going to now just plug it into this formula. A of n is equal to 3, that first term, plus n minus 1 times the 6, the common difference. We need to now distribute 6 into this here. So we're going to say A of n equals 3 plus 6n, which is 6 times n, and then minus 6, 6 times negative 1. Just combine the 3 and the negative 6, which would make a negative 3. So A of n is equal to 6n minus 3. That is our rule. So now we can figure out what the 20th term is. We wouldn't want to keep adding 6 every time. That would take a little bit of time to get to the 20th term. But here, if we have the rule, we can just now say 20 in here times 6 minus 3. That's all we got to do. Is 6 times 20, that's going to be 120 minus 3. And 120 minus 3 would give us 117. That's our 20th term. So that's a whole lot faster than trying to keep adding 6 and figuring out what that 20th term is. Over here on number 6, our first term, as we can see, that first number, A of 1 is 8. And then our common difference, we are going down. The numbers are getting smaller, so we know our common difference is a negative number. So you're going down by 5, it looks like. So negative 5 is going to be our d, our common difference. So go ahead and plug that in to our formula. So A of n equals the first term, 8, plus n minus 1 times negative 5. We're going to have to distribute the negative 5 into here. So it will be 8 plus negative 5n, and then negative 5 times negative 1 will be positive 5. And then just combine the 8 and that 5 together. That's going to give us 13. So A of n is equal to negative 5n plus 13. So there's our rule. So you see how easy it is to write the rules now that we have this formula, and all you need to know are those two things there. And as long as I give you a sequence like this, you can figure that out very quickly. So now with the 20th term, just plug in 20 for n. So it's going to be negative 5 times 20 plus 13. So it's negative 100 plus 13. If we take 13 away from 100, it's going to be a negative 87. So that's your 20th term in this one, is negative 87. Now at number 7, we can see our first term right here, negative 1. Our common difference, it looks like it is going up, so it is getting bigger. So it's a positive common difference. It looks like it's going to be just 1/2. So going from 0 to 1/2 is just a half. So that's going to be A of 1 is negative 1, and then our d is a 1/2, a positive 1/2. So we're going to plug that into our formula. So A of n equals negative 1 the first term plus n minus 1 times the 1/2. Remember, n minus 1 is always that way. That's the part of the formula. So you distribute the 1/2 into here, so it'll be a 1/2 n minus a half. And so we're going to see negative 1 and a negative 1/2. We can add those together. That would be negative 1/2, which is the same as 3 over 2. So we might want to use 3 over 2 instead. So A of n is equal to that 1/2 n. Common difference is always your slope, remember. And then it's minus that 3 over 2. That's like the y-intercept. So remember, these are all linear equations. Remember, the 6 is the common difference. So we already knew what number is going to be up in front of our equation, even when we just found it right here. 6 is going there. But to figure out that number, then you want to figure out this here using this little formula. It helps us. That is the y-intercept number. So you can also use y equals mx plus b even to figure these out. If you know what your slope is, you can just plug it in. You can know here's a point. X would be 1, y would be 3. That's an ordered pair, so you could plug that in and actually solve for b and find out what that number is, negative 3. But I think this is just as easy, and maybe even easier to do it this way. Number 8 over here, we're going to be seeing that 0.7 is our first term, of course. Oops, I forgot the 20th term on this last one, number 7, sorry. So we're going to say half times 20, which would be 10, minus 3 over 2. So it's going to be 10 over 1 minus 3 over 2. We get common denominator, which will be 20 over 2. minus a 3 over 2, so 20 minus 3 is going to give us 17 over 2. So there's our 20th term right there. And now we could say 0.7 on this next one is our first one. The common difference looks like I'm going down. They're going into the negative region, so negative 0.5 it looks like on this one. Negative 0.5, which is like a negative 1/2, but we'll use a decimal here. And then just plug everything into our formula. So the first term is 0.7 plus n minus 1 times our common difference. So we're going to get a negative 0.5n and then a positive 0.5 here. So our 0.7, negative 0.5n plus 0.5. So 0.7 and 0.5 would make a 1.2. So it's going to be negative 0.5n plus a 1.2 as our rule. That's the equation. And now the 20th term, plug in 20 again right there. So it's going to be negative 0.5 times 20. That will be negative 10. So we'll see negative 10 plus 1.2, and then just when you take 1.2 away from negative 10, we will get negative 8.8. So there's our 20th term on this one, negative 8.8. All right, here's our joke of the day. How do crazy people go through the forest? Well, they take the psychopath. The psychopath. All right, so continuing with our extra practice, number 9. This is on now page 225. This one's a little bit different. It says write a rule again, but it's going to give us something different here. It's not giving us like those first 4 terms. It's giving us a of 12, which would be the 12th term, is negative 13, and it's also giving us what the common difference is. It says after we write the rule, it says then graph the first 6 terms of the sequence, and it gives us a little coordinate, little grid for that. So what we know here is we have a of 12 is equal to negative 13, so that right there is, that's your n. The 12 is the n, the negative 13 is the a of n, and here's our d, our common difference. So when we're actually looking at that formula again, here's our formula. We have a few things here. We have a of n, a of 1, n, and a d. So we actually have 3 of these things right here. We have everything except the first term. So what we need to do is plug everything in here, all these numbers. So I'm going to plug in 12 for n, negative 13 for the a of n, negative 2 for the d, and then I got to figure out, okay, what's my first term? What is the a of 1? So let's go ahead and plug everything in. So now it's that negative 13 here is equal to a of 1. That's our variable. That's what we're trying to solve for. 12 minus 1, because n is 12 in this one. D is negative 2. So we know 12 minus 1 will be 11. So we're going to see that's going to now be 11 times negative 2, which will be negative 22 there. So we'll have negative 13 equals a of 1 minus 22. Just add the 22 now to both sides. And so now we'll see negative 13 plus 22. So a of 1 is a positive 9. So there's our a of 1. So now that we know the first term and we know the common difference, we can now write that rule with this formula. So that will do now just what we did before. So put those two things in. So your first term, 9 here, negative 2 over here. Distribute the negative 2. So that's negative 2n plus 2. So 9 minus 2n plus 2, and then 9 plus 2 would be 11. And so there you go with a of n equals negative 2n plus 11. There's our rule. That's what it said. Write the rule. We got the rule. And then it says to graph the first 6 terms. So we can do a little table of values here for this. It's like an x and a y t-chart. Remember, n would be considered x, a of n is the y. And so our first 6 terms, we know what to use for n over here. It's just 1 through 6. So it's just number 1 through 6 for the first 6 terms on the n, that we're going to plug those in. Now our first number we know is 9. We know the first term right here, a of 1 is 9 already. So we can just start right there. And we also know that we have a negative 2 as the common difference, which means we're going to subtract 2 every single time. We don't actually have to plug these numbers in and work them out if we know what the pattern is. We can just say, okay, 9 minus 2 is 7. 7 minus 2, that's going to be 5. The next one's going to be 3. 3 minus 2 would be 1. 1 minus 2 would be negative 1. And so we could just get those numbers pretty quick just by using the pattern. So now that we have all 6 ordered pairs, we can go over to the graph, put our our kind of axes on here, our x and y axis. So this one's going to be our x axis down here, but we're going to label it n, and our y axis this way we're going to label it a of n. And now we're going to just plot these on here. It should line up into a nice line if we were to connect the dots, but we're not going to connect dots here. So 1, 9, that's going to go at the very top. So here's 1, 2, oops. So that's 1, 2, 3, 4, 5, 6 down here. And this is going my ones up as well. And then there's 2, 7. Then the next one's 3, 5. Go ahead and plot that one. Then 4, 3. Then we got 5, 1. Now we're getting close to this like n-axis here. We're going to go below the n-axis now. And this next one, 6, negative 1, just goes one below that n-axis there. And there it is. So that's graphed. You don't connect the dots in a sequence because these are all separate points here. We're not going to connect those dots on this one because it's a sequence of numbers. Okay, so in the next two problems also says to write a rule for the nth term of the sequence, but it does give us, again, something a little bit different. Doesn't give us those first 4 terms. It doesn't even give us the common difference on this one. It gives us really 2 of those terms. So it shows us the 8th term on this one is 59, the 13th term is 99. So it gives us 2 terms in that sequence. Then they want us to write the rule. So I'm going to show you one way with number 10 and a different way with number 11 that you can figure this out with. And you can decide which way you want to kind of pursue and use more often. But this first way is going to just continue to use that same formula that we've been using. So this is more kind of the arithmetic way of doing it. Now on this one, what we know is we know our n numbers are the 8 and the 13. Our a of n numbers are these 59 and 99. So we know those. So 8 is an n, 59 is an a of n, 13 is also an n, 99 is an a of n. So what we could do here is we could make 2 equations out of this. Plug this in, make 2 equations, and now we would have what's called a system of equations, and we've done these before. So if I start with this first one here, a of n is 59, so I could start with that. So I'm going to say 59 for the a of n is equal to a of 1. I don't know that here yet, so then I'm going to say plus n minus 1. Well, 8 is n. 8 minus 1 is 7. So it's going to be 7 times d. So it's going to be plus a 7d. That's our first one. Then for the next one, you can start with 99 as the a of n. So just underneath that, so 99 equals a of 1. I don't know that one here either again. But then on this one, 13 is n. 13 minus 1 will be 12, and now I'd have 12d. So I have 2 separate kind of rules here that I can now put together. I could put these now together, just combine them. It's called the elimination method. First, I would need to subtract everything down here. So change all these signs to their opposites. That way I can cancel out these a of 1s, and then I could solve for d and find out what d is. That would tell me my common difference. So I change all the signs first and cancel out the a of 1s. So now I have 59 minus 99, 7d minus 12d. So that's going to give me a negative 40 equal to a negative 5d. And I'll divide by negative 5. So that's going to give me negative 40 divided by negative 5, which would be positive 8. So my common difference is 8. So now that I know that, I can plug it back into the formula and use one of these points here, or one of these numbers. I can either use the 8th one or the 13th one, it doesn't matter. And I'll probably always use the smaller numbers, so I'll probably use the 8th one here. So I'm going to plug everything in except for a of 1 now. So I'm going to say, okay, 59 again is equal to a of 1, which I still don't know, plus 7, because remember that's right here. That's basically plugging it into this equation. I'm actually going back into this equation here, taking 8, plugging it back into my blue equation right there. So 7 times d is now 7 times 8. So that's 56 right there. So now we're just going to subtract 56 from both sides. So 59 minus 56, that's just going to give me my a of 1 is 3. My first term is 3. So now that I know these 2 things, I can write the rule. And so I'll write the rule as plugging it into my formula again. So 3 here plus n minus 1 times 8. I'm going to distribute the 8 in. Remember my d was 8. And so it's going to be 8n minus 8. So I'm going to see 3 minus 8 there. Take 3 away from negative 8. That's a negative 5. So the rule for this one would be a of n is equal to 8n minus 5. Remember, as soon as I knew what the d was, I knew that had to be an 8n there. I just didn't know what the first term was to figure out what this last number was going to be there. Okay, so for number 11, I'm going to do it a little differently. I'm going to do it the way we've done these before with when we talked about linear equations, and pretty much using y equals mx plus b for this one. So this one we can also do it this way. Now, we would need to see these as two ordered pairs. Now, so this would be our x right here. This would be our y. 27 is the x. This negative 8 is the y. Okay, so remember, this is your term number, which is always the x's in these. These are your a of n's, so that's always the y. So we can see that as our ordered pairs, and then what we could do, we could start by finding the slope, which would be m is equal to subtract the y's over subtracting the x's, the difference in the y's minus the difference in the x. So that would be subtracting the y's. I could do negative 8 minus negative 5 if I want to start with this last one here. So negative 8 minus a negative 5 over, subtract the x's now. I'm going to start with this one. Since I start with negative 8, I got to start with 27. So 27 minus 18. And so this is a double negative on top, but we're actually going to make that into a plus. So if I take 5 away from negative 8, that's going to be negative 3. And then 9 minus 8, or 27 minus 18 is 9. And so that now simplifies to a negative 1/3. So negative 1/3, that's my slope number, which is be considered our d. That's how you could find the d. So that might have been a little faster to get to that d number. We would then need to find out what the b is. So to figure out what b is, we're going to go back into our y equals mx plus b. We got to pick one of these 2 points. I usually just pick the one with the smaller numbers. So using these numbers, we're going to say, okay, y is negative 5. So I'm going to put in negative 5. So this is going to be into our y equals mx plus b here. So our y on this point, I'll use this one here. So I'll use these numbers. So right here, negative 5 is going to be my y equals m, which we know is now negative 1/3, times the x, which is 18 in this one, plus the b. Now 3 and 18 can cross cancel. That can become a 1, 18 can become a 6. So we're going to see negative 5 is equal to basically negative 6 plus b. And now I just got to add 6 to both sides. And so that's going to give me b is equal to positive 1. So b is equal to positive 1. So now we can plug it back into here. So basically we need to realize it's going to go back into our formula. So remember our formula, this is y is a of n. So we're actually going to write a of n here. I'll do it in black. So our answer here, a of n, oops, didn't go black. There we go. A of n is now equal to, so that's our y. M is the difference, the common difference, which would be 1/3, and I'll use n for x, and then plus 1. And there's our rule. So using y equals mx plus b, we could also figure it out as well, and that might be easier for you to do. And if you can do that to get the rule when you're given this kind of situation, because this situation is like 2 ordered pairs. You have 2 x's and 2 y's. You can find the slope. You can then find the y-intercept, which is the b, and then you have your your mx plus b is right here, and you just write it as more into the sequence or notation. A of n is the y, n is the x. All right, so back to 223. So in your vocabulary for an arithmetic series, what you're going to say for that is basically it's adding all of the terms in arithmetic sequence. So the expression formed by adding the terms of arithmetic sequence is called arithmetic series. So that's what you're going to do. You're going to say for this one, just say for arithmetic series, it's adding the terms of an arithmetic sequence. And so for doing that, we actually can find the sum of a finite arithmetic series, not an infinite one. As the numbers keep getting bigger and bigger, we can't do that, or smaller and smaller. We cannot find it of an infinite series, but we can find the sum of a finite series if we have a limited number of terms. So here's our formula. S of n would just be your sum, and then we have our n right there. That's going to be your term number of how many terms you have. basically, and then a of 1 we know is our first term. A of n will be the last term, so you can write this down here. A of 1 is your first term. A of n here in the formula is the last term, the very last one, and it's all divided by 2. Now I usually like using it like this. I put the n typically on top, so instead of adding these and then dividing by 2 and then multiplying by n, I usually add these two, multiply by n, and then divide by 2 at the end. So you might want to write this formula down. It's a little bit of a different, it's the same formula, just a little converted a little differently. We could add the terms together. If there's a small amount of terms, then that's not too hard just to add the terms together. But if there's a large amount of terms, you know, like 20, 30 terms in this thing, then you're definitely going to want to use the formula. But if there's only like 5 terms that you have to add together, then that's not too hard. You don't have to use the formula to add up 5 numbers if you know those 5 numbers, in fact. So, but the formula is definitely helpful when you have to add, like, you know, the 100 terms or something like that, or 50 terms, or 40 or 30 or something like that. Okay, so number 12 there on our last one on our extra practice, back to page 225. It says find the sum, and remember this notation from the 8.1, that's the summation notation or sigma notation, saying we're going to take the sum of this now. And so remember, we have 3 things here. So we have our top part is the last term, that is the final term, or that tells us how many terms are going to be in this, and that really is the n that's going to be in the formula. So that there's 22 numbers or 22 terms in this finite series, and we're going to start with the first one. It says I is 1. I don't usually like I, but they're using I as a variable here. I usually wish they would put maybe like n or x down there instead. And then our rule is over here. Here's our arithmetic rule, 5 minus 2i, or we could say negative 2i plus 5. It's more of that mx plus b kind of a form. So what we need to know for our formula is we need to know the first term and the last term. That's the 2 things we need to know for the formula. So start with the first term. What is that first term? To figure out your first term, you just got to plug in 1 for your variable here. So it's 5 minus 2 times 1. And that will give us our first term. So 2 times 1 is 2, so 5 minus 2 would be 3. Our first term is going to be 3 in this series. And then we have to find the last term. So that last term is going to be plugging in the 22 for n, or 22 for this letter I in this case. So 22 is going to go into our rule. So our last term, our 22nd term, you're going to plug 22 in now. So it's 5 minus 2 times 22, and that's going to be negative 44. So 5 minus 44, take 5 away, it's going to be a negative 39. So your 22nd term, your very last term, is that negative 39 number. So now we have everything we need to be able to plug it into our formula, our sum formula. I usually just put S out here for the sum is equal to n, which is that 22 number. So n is 22. A of 1 is our 3, and a of n is 39. And it's all divided by 2. So we plug everything in. So 22, 3 plus negative 39. Let's do what's in the parenthesis first. Take 3 away from that. It's going to be negative 36 now in the parenthesis. 22 times negative 36 on top is going to give us, and then divided by 2. So let's actually do this on the calculator really quick so you can see what I just did. 22 times 36, that's going to be 792. Now it's a negative number there. I can make it negative like that. And then just going to divide by 2. That gives me my negative 396. That's the sum of our terms. So the sum of all the terms is a negative 396. All right, so that concludes our lesson here on 8.2. Just go ahead and want to go on to the big ideas assignment, get that assignment done, and I'll see you in class.